Well, we're back, and let's go on to the next segment, which is we're going to take a look at touch gestures for mobile, and this is the Fingers package by Digital Ruby, this is a way of implementing common touch gestures. Let's go ahead and take a look at their page. And this essentially has all the common touch gestures included in this package. So there's tap and tap and hold and swipe and pinch. There's even a virtual joystick and a virtual D-pad. Also, what I think is really cool about this is that we can use common keys and key combinations inside the editor for previewing gestures so that we can see what the effect would be just using our keyboard and our mouse. So we don't have to be hooked up to our Unity remote to be able to test the functionality of this. Also, mouse clicks can be simulated as touches. So it means that if we have a simple mouse click script like our click to move right now, which looks at mouse clicks, then Fingers will translate those into proper touches, and we can go ahead and just use our existing mouse and keyboard script in this particular case. So today what we're going to implement is a 2-finger drag to rotate, so that will move the camera, and then we can emulate this in the editor. And so we're going to control the camera with a gesture. Now to do that, we're going to need to go ahead and write a C# script. So let's go ahead and come back to our game. So we're back here in Unity, and I'm going to go ahead and create a new C# script. And I'm just going to throw these into the root of our project. Probably should create a folder for it, but I'm just going to throw this in the root of our project because we'll know where they are. But I would probably suggest that if you're doing your own project, that you create a scripts folder and go ahead and do it with that. So let's name this one camera, follow, and rotate. So we've now created a camera, follow, and rotate script, and we're going to go ahead and open this for editing. And here we are in wonderful monodevelop. So this script is going to move the camera based on its starting position relative to the player character. So I guess for us, we want to make sure we pick a good start position. But when we write this first half of this script, it will not rotate until we implement the finger gesture. So I'm going to go ahead and write just the simple follow the character part. This you can use. It's not related. This first section is not related to the package at all. So anybody out there can go ahead and use this as an example of how to make a follow script. And then we'll rotate the camera using the finger gesture. So I'm going to go ahead and just simply clear out our base content. All right, so we've just cleared our content. So we need to make two variables, one public, one private. We want to make a public transform. That's our target, because we're going to need to target something with the camera. It needs to follow something and rotate around something, and that's going to be our player character, and we're going to use our player character's transform. And then we want a private vector3, and we're going to call that camera offset. And this is going to be the difference in space between where the camera is and where the character is. So we're going to go ahead and just sort of hold that difference in a private variable called camera offset. So we're going to need to set the camera a number of times. And we'll see how we do that. So we're going to create a very simple function called set camera. So start off with void set camera. And then what that's going to do is we're going to say, take our transform. So this script is going to sit on our camera. So we don't need to address the camera specifically. We can simply ask for the transform. And so we're going to say transform.lookAt. And then what do we want to look at? We want to look at our target dot position. So that is a transform already, so all we need is target dot position. So we're saying to the camera, when we set the camera, look directly at the target from wherever you are. And then we want to record our camera offset. And our camera offset is going to be equal to the transform position of the camera, because remember this is on the camera, and then we want to subtract our target position. So very simply we're saying we just want the difference between our position and the target, and that's our offset, and then we are looking at our target. So we're going to set that up when we first start the game. So we want void start. So we're going to have void start. The first thing we're going to do is just simply set that camera. And then in late update, remember there is update and late update, well, we need the void late update. Late update is an update function that happens after all of the update functions have happened in the game. This is after the player has moved, after all of the main objects in the scene have updated, and then in late update, we'll then go ahead and move our camera to our new position. So we're going to try to find the new position where we want to have the camera. So that's going to be a vector 3, and it's going to be our target camera position. I'm going to shorten that to cam pause, but our target camera position is going to be equal to target.position plus our camera offset. So this is essentially just reversing out what we did in set camera. We find the camera offset by saying it's the difference between the transform position and the target position, and then we set our target position for the camera as just simply putting it back in, take our target position and add that camera offset. Now we want to move to it. So let's take our transform position. Again, remember that this is on the camera, so that transform position is the camera's transform position. And we want to move it. We want to move it smoothly, so we're going to ask for a vector3.lerp, or linear interpolation. And we're going to move from one place to another place smoothly. And so in vector3.lerp, we're going to move from our transform position, where we currently are, and we're going to move to our target cam pause. Now, the third value is essentially how fast we are going to move from point A to point B. And so we need a value for that. So let's go ahead and make a public float, and we're going to call it camera follow speed. And that's going to be equal to 1.0f. And we want to do that just so no matter what we do with this script, even if it's too slow, at least the camera will move. It won't have a value of 0 and just not do anything. So let's come back here and say that we're going to lerp at the speed of camera follow speed. And we're going to multiply that by time dot delta time. So let's go ahead and save this script. Let's come back to Unity and see whether we've made any massive errors. Oh, look at that. Properly compiled. Woohoo. So we need to add this script to our main camera. So that's our main camera. And then we want to go ahead and add our camera follow and rotate to the main camera. And we can see that we've got that camera follow speed already set to 1. And who is our target? Our target is the Viking. So let's go ahead and save, and then let's enter play mode to see if that works. So we now click, and we can see that the camera is following, and we can see that it's smooth. It starts off with a little bit of a feather, and then slowly, comes to rest where the character is moved. I feel that this is a bit too slow, and I'd like to speed that up a little bit. So I'm going to exit play mode. I'm going to go ahead and take my camera follow speed, and I'm going to increase it. I'm just going to pick a random sort of number at this point and just call it 5. See how that looks. Save and enter play mode. And camera's still got some nice smooth feathering at the beginning and the end, but seems to stick with him a little bit more. But now we've still got a problem. We can't turn around and see what's behind us. We can't look down in any other direction. It's simply following at the same distance and offset that the current camera is. Now, looking at the game view, if we want to be in a different position, if we feel we're too far away or too close, then what we need to do is adjust the position of the camera. And one of the ways that we can do that is that we can grab our view, and we can come up with a good view in the viewport. And then we can select the main camera, and then we can say game object, and then we can say align with view. And so now we've changed the view of the camera. So when we go ahead and start, now we're going to have a different offset. You can see that we're closer, slightly closer than we were before. Now this may be too close, but I just wanted to show you that way of setting up the camera, because this particular script is working based on where the original position of the camera is. And so one way to frame it is to simply frame your scene view camera and then force the game view camera to go ahead and align with that same view.